Hello, everybody. Now we are going to go through this question is about the geometrical meanings of some sets defined in R3, assuming that we have three nonlinear point A, B, C. This is for the course Maths 1141 at University of New South Wales is about week 3. Okay, the first part of this question is basically the definition of a plane in R3. If we have a vector notations, we have the set of the vectors defining planes in R3. If we have a point and we have a two-directional vector, but these two directional vectors should be a specific way. Non-linearity here is an important part. If you have A, B, C points is a linear, like on the line, then you will not be able to obtain a plane. If we have three non-linear points, then we will have this kind of vectors. It could be any angle between them, it doesn't matter, but they are not collapsed together. They are not collapsed in the directional way. So when we are talking about the vectors, we consider vectors objects giving us the direction. And a multiple of the direction is what we think, right? If you have a vector, if you multiply with a scalar of that vector, then it is in the same direction. So opposite directions are in the same direction in terms of the vectors as well. Because what I mean by that, if you have two opposite vectors, they are linearly dependent, right? They are linearly dependent. If you have two linearly independent vectors, as we have here, any angle is perfectly fine. Then if you have a given a point, then you will be able to obtain a plane equation in R3. Right? And this is the situation here. OA, A is a point. We can take it A or B or C, but in this given equations, in the question given equation, we have a point. So this is a plane passing through the point A, and in the directional vector A, B, A, C. Right? That's the definition of it. But this is a set notation. That's what I wanted to say here. It reminds you what it was the set notation, how we express the sets. Like this is the elements of the set. So the elements are the points in R3. And satisfying this condition, and S and T here runs through the all real numbers. Okay, and there is no differences between this set and this set here. This set says basically not the point P's, but the OP vectors. So the point P here is just a general vector, general point on the plane. Just a general point, because we would like to define this equation. This equation is a point, and then you have two directional vectors. By multiplying the coefficient of S, you are basically taking this vector AB and stretching or squeezing anywhere you like. And the C vector here, again, you're stretching and squeezing, and you're looking also the parallel ones here and the parallel ones for AB as well. So this is how you get the plane B, right? So this is the how you imagine the plane geometrically. So what I want to say here, it is equivalent to say that the points in R3 satisfying this condition is equivalent to say the vectors OP satisfying this condition. These two sets are exactly the same set. We can express in this way, we can express in this way, just a note for you. Okay, the second part of this question, we have a restriction for S. It needs to be 1. So we have only one parameter then T. If you have two parameters, you have the plane. If you have one parameter, you have a line in R3. So once we realize that S is equal to 1, by just looking at this part of the equation, we will immediately say this should be something to do with line, okay? And now S is equal to 1. We have this vector. What is this vector? It is good to understand, right? And OA, OB, it's just a vector addition. OA plus AB, from here to here, here to here, by vector addition, this will be just OB. So this is what I'm saying here. OA plus AB is equal to OB, vector addition. So instead of this part, we can put OB here. Then that will be the point that passing through the line passes through. And in the direction of the direction vector will be AC. So AC is this one. In the direction of AC could be anything parallel but passing through the B. So this S here, the yellow line here, is our S in that moment. So the line equation through the point B in the direction of AC is the answer for this part of the question. Okay, S3. Now we don't have the whole parameters S and T running through from 0, 1, 0, 1. It means that we don't have a plane. We have a cut plane. So it's a parallelogram because S is the coefficient of S from 1 to, runs through from 0 to 1. So from here to here, 1 unit. Another one running through the 1 unit, so we have all these parallels to it. And the T, we are looking at all the parallels to the AC, and that is limited. It means that will be a parallelogram. Nothing can be. For S4, now we have a restriction, and the coefficients are the same, so it goes down to the one parameter. So we should expect a kind of a line or a line segment, but it can't be a full line because you have a restriction and 0 to 1, 2. It cannot be the vector space. The line itself is going from minus infinity to plus infinity is a vector space in R3. If it is passes through the 0, or a fine space if it is not linear, if it is not the origin, if it's that's an affine plane. So this should be, by looking at the restriction, it must be a line segment. Now S is equal to T, what it means for us, let's check it. S is equal to T, so we have AB plus AC vector. Now we need to understand what does the AB plus AC vector means, or how can we simplify it. If you look at recall, this is the example 4 in your algebra notes, page 7. If you look at that note, and you will be able to see this fact with AB plus AC, if you have this kind of situation, then when you add these two vectors, it will be the twice of this AI. Or AI, the vector AI, is equal to 1 over 2, there's a half the medium of the AB plus AC. Now let's use this fact and try to understand what does the set S4 is. Now, so that is the situation. I am putting this object, instead I'm putting 2 AI. This is coming from the fact. That S, instead of S, I'm using a lambda from 0 to 1. That's for the change. Now, instead of to understand a bit more, I would like to say 2 lambda is equal to mu. If lambda is equal to 0, mu is equal to 0. If lambda is equal to 1 over 2, mu is equal to 1. So I can rewrite this set as this one, because this equation will be mu from the 0 to 1. It means this is just a line segment, so it covers the whole line segment. It is not the half of anything, so it is clearly the AI, the line segment AI, with the full length. And this length, as we know, because of the addition, will be 1 over 2 AB plus AC. just given to us from this factors. That's what I wrote here. It's not a big important, but to find this is the solution. Okay, last part of this question is about the set of the vectors, set of the points satisfying this condition, S and T are between 0 and 1, but we require the coefficient of S is smaller than coefficient of T. We know from the above, if it is between 0 and 1, right, this is this case, it is a parallelogram. So without the restrictions of the coefficient S smaller than T, we have a parallelogram. So this is what we know. We can use this factor here. And then we have a restriction S is smaller than T. Now, it means we need to have halfway through, we need to have the triangle inside of this parallelogram, which will give us this set. So this is guess. This is the understanding after given this point. Now we need to dig in more because we need to understand what it means this coefficient is smaller than this coefficient. Okay. So that's what I'm trying to explain it here. This is a side work or side thinking. Assume that we have the point 0, 0, and point 1, 0, and 0, 1. Just we would like to understand this coefficient of CA, the coefficients of CB, what it means if it's smaller than. So we know that if the midpoint is I, OI, from the previous work that we've done, 1 over 2 is OX plus OY. Yeah, you know that one. So if we have a point here in this part of the half of the YX, XY, say we have a point J here, I assume that 2 over 3, 1 over 3 point that we are talking about. And in this case, we will write OJ as X will be the 2 over 3 and Y will be 1 over 3. In this case, the coefficient of or X will be bigger than the coefficient of T, right? This is what it is here. On the other hand, if we take the point here, let's say, for example, 1 over 3, 2 over 3, then we can write the vector OK as 1 over 3 OX, 2 over 3 OY. Then we see that in this case, the coefficient of S is smaller than T. So that is this area. So if the coefficient of OX is smaller, then we have this area. It is the same here if we have the coefficient of CA is smaller than the coefficient of CB will give us this yellow area. Yep, I think it's clear. And the second part of this question, using the ideas in A, find a parametrization of the set S of all points located on the boundary or inside of a triangle ABC. Okay, we have a triangle ABC, and the midpoint is 2AI is equal to AB plus AC. And the points in this area will be like lambda AC plus 1 minus CAB, where lambda runs through from the 0 to the 1, 2. This is exactly the work that I've demonstrated here. This is where it's coming from. And then the points here will be just AK, and mu will be because the coefficient of AB is smaller than the coefficient of AC. And the summation has to be the 1 because you have the whole. So basically this blue area is the rows of the arrays and the rows of arrays here. So we want to all of them. We want the yellow area and we want the blue area as well. So together of this condition means that we want this coefficient between 0 and 1, right? Because that is what it is, right? Otherwise, you will be increasing the length of AJ and decreasing the length of AJ. So writing of this way, it means that the full of the length of the AJ that we are talking about. So just writing these two equations together, it will be the coefficient of S and T needs to be between 0 and 1. Because when you add this coefficient has to be 1, because this length is the 1 unit. The length of the AJ is 1 unit for all, or length of AK is 1 unit. So this is why you have S and T run through the 0, 1. And S plus T is equal to 1. Right. The addition of that has to be 1. The coefficient additions of these coefficients has to be 1, and they should be running through the 0 to 1, so that you will have the full length of these arrays. And basically this arrays is the full of the question for you. How should I? Okay, this one maybe. So you have the arrays like that. Infinitely many arrays like that. I think, I hope it is clear for all of you. And that's all for this question. Thank you very much.